Hey guys, so in this video, we are going to explore solving inequalities. So our objective is just that. Students will be able to solve inequalities. We will be just basing these in one variable for now. Later on in this course, you will do two variable inequalities, but for now, we're going to focus with just the one variable. So solving inequalities is very similar to solving equations. In fact, all of the steps are exactly the same. Your main goal is to get all of the constants to one side and all of the variables to the other. The biggest thing, though, that you need to make sure that you remember is that when you divide or multiply by a negative number, you need to make sure that you flip the inequality sign. You want to make sure that if the number that you are multiplying by or that you are dividing by, the one that you physically are moving in the inequality is negative, then you flip the inequality symbol. And that's the hardest thing for students to kind of think about, and here's why. If I have a number 4 is greater than, not 8, 3, that is a true statement, right? 4 is indeed greater than 3. And we've learned in math that you can do anything to an equation as long as you do it to both sides. So if I multiply my 4 by 2, as well as my 3 by 2, then I'm going to get 8 is greater than 6. And that is still a true statement. But if I decide to multiply this by negative 2, then I'm going to get negative 16 is greater than negative 12. Well, that statement is actually false because our negatives work in the opposite direction of our positives. So in our positives, as we get further and further away from 0, our number gets bigger and bigger. But when we look at the negatives, and we're talking on a number line, so if here's 0, as I go to the right and get further away from 0, my numbers are getting bigger. But as I go to the left and move away from 0, my numbers are getting smaller. So negatives, because they work in the opposite way that positives do, you have to make sure that you flip the symbol. So to make this true, I need to switch it. Negative 16 is actually less than negative 12. And again, this only works if the number you are multiplying by is negative. If the number is negative that is there already, then that doesn't change. And I can show you that here as well. If I have that negative 4 is less than negative 2, actually we'll just make that a positive 2, say it that way. That's a true statement. When I multiply this by positive 2, then I get negative 8 is less than 4. Still true. It doesn't change until I multiply by a negative 2 to get positive 16 less than negative 8. Then it's false, so I have to change the symbol to make it a true statement. Okay. So now let's practice solving these inequalities. So let's look here first at number 1. This is saying that we have 5x, that's 5 times x, is greater than 15. So to get rid of the 5, I'm going to divide it to both sides. Since the number that I am personally dividing by is positive, then I don't need to change the symbol. That will leave me with x is greater than 3. If we wanted to put this on a number line, you would just draw a number line. You would put 3 in the middle, 2 above it, 2 below it. When we think about this and think about possible solutions, we know that 3 is equal to 3. So if I plug 3 in for x, 3 is not greater than 3. So I'm not going to use it as an answer, but it is my placeholder. So I'll use an open circle, and then I'm going to shade in the direction of the numbers that are all bigger than 3. So that would be this way. Looking at number 2, I have that x divided by 3 is greater than or equal to 6. So I need to take this and I need to multiply by 3 because x is divided by 3. So to undo that, I multiply. So I get that x is greater than or equal to 18. Once again, the number that I physically moved was positive, so I don't need to change my sign. To graph my answer, I would put 18 in the middle, put 2 above it, and 2 below it. Now when I think about it, I know that 18 is equal to 18. Since I have the equal sign down there, 18 is a solution. 18 is greater than or equal, because it's equal, to 18. So instead of using a closed circle, instead of using an open circle, I'm going to use a closed circle. Since I want all of the numbers that are greater than 18, I'm going to shade towards my numbers that are greater than 18. Now let's look at number 3. Number 3, I have -3 times x is greater than or equal to 12. Since I'm multiplying -3 and x, I'm going to divide by -3. The -3's will cancel, and I'm going to be left with x and then -4. Since the number I divided by was negative, I'm going to switch the symbol. A good strategy would be, if you notice that there's a negative on the number you're going to multiply or divide by, go ahead and highlight your inequality symbol. That means you're going to have to flip it, so it helps you remember later. Now, when I want to graph this one, I'm going to put -4 in the middle, and I'm going to put 2 above it, and I'm going to put 2 below it. Just remember that your numbers go backwards on the negative side of the number line. Since I have an equal sign on the bottom, I'm going to have a closed circle at -4. And then I want all the numbers that are smaller than -4. So that means I'm going to shade in this direction. You guys try and do number 4 on your own. You should have subtracted 2 from both sides to get that x is less than 3. Since it's strictly less than and cannot be equal to 3, you'll use an open circle and you'll shade to the numbers that are smaller than 3. Two-step inequalities work identically to two-step equations. You just want to move the constant first and then move the whole number. So we're going to move our 4. Since the 4 is positive, I'm going to subtract it. Remember, you're always looking at the sign in front of a number, not behind. The negative here goes to the 3 rather than the 4. So 4 minus 4 gives us 0. Don't forget to bring down that negative with the 3x. And then 0 minus 4 is -4. Our next step is then to get rid of the -3. So we will divide by -3 to both sides. Since the number we divided by was negative, we're going to switch our symbol to be greater than. -3 divided by -3 gives us positive x. -4 divided by -3 gives us a positive 4/3. Remember that a negative divided by a negative is a positive. So, switching our symbol gives us x is greater than 4/3. The easiest way to graph this is to put 4/3 in the middle. The next whole number would be 2 and 3. The next above it, and then the next smaller whole number would be 1 and then 0. Since it's greater than, we'll have an open circle, and we're going to shade to the numbers bigger than 4/3. Numbers 6 and 7 are very similar because they both have fractions, but the order in which you're going to do things is a little bit differently. Because number 6 is one giant fraction, you're going to need to multiply first. Since number 7 has a fraction separate from a whole number, we first need to get rid of the whole number 5 before we can get rid of the fraction. So for number 6, you would first get rid of the 4. So you're going to multiply by 4 to both sides. The 4's will cancel, leaving just the top piece. So 3x plus 1 is greater than -20. We then need to subtract the 1. So we get 3x is greater than negative 21. Noticing that negative 20 plus negative 1 is negative 21. Or noticing that both of them are negative, so we need to add them. The last step would be to divide by 3 to get that x by itself, giving us that x is greater than negative 7. Because the number that I divided by is positive, I don't need to change my symbol. Putting the negative 7 in the middle, and then putting 2 that are bigger and 2 that are smaller, I will have an open circle because negative 7 is not a solution. And then I will shade to the bigger numbers, so point towards the positive direction. Number 7 is very similar, but instead of multiplying first, I actually need to subtract the 5 first. So I minus the 5 from both sides, giving me negative 2/3 x is less than 1. I then need to multiply by 3 to get rid of the 3 in the bottom. You could also multiply by 3/2, but most people prefer to take this into 2 steps. So negative 2x is less than 3. My last step is to divide by negative 2. Since I'm dividing by a negative number, I need to switch my symbol to be greater than. 3 divided by negative 2 is just negative 3/2. You can leave it 3 over negative 2, but a lot of times we tend to float that negative up to the top so we don't forget about it. Making our number line, we have negative 3/2. And then the next bigger whole number would be negative 1, and then 0. And the next smaller negative would be negative 2, and then negative 3. It's an open circle because we don't want to include negative 3/2. And we're again going to shade towards the positives. You guys try number 8. When you solve number 8, you should have minused the 17 from both sides, then divided by 3 to get x is less than or equal to negative 7. Graphing that, you would have a closed circle at negative 7, and then you would shade down towards the left-hand side, towards the numbers that are smaller than negative 7. Tomorrow in class, we will go into a little bit more depth of these and answer any questions that you have, and then we'll do some classwork for extra practice. See you then.